Okay, so hello everyone. Today we will see now a stack. Actually, in last video we have seen how we can create a node. So this was the code for creation of node in C++ for binary tree. So if you could not still understand how we can create a node for any binary tree, so you can simply go back and you can watch the video. I have added the link of that video into I button. You can simply go through that. After that, we had seen how we can do some recursive pre-order traversal, where I have explained about in order and post order also. So you can refer that video also. The link of both of this video I will share in the last button too. Okay. So now we will go for here stack creation. That is our today's motto. So we know that what is stack. So stack generally looks like this, where we call this data structure as a last in first out kind of data structure. So this is the structure of stack, where we call this data structure, as I told you, as last in first out. So what is the meaning of last in first out? Actually, we know that the word is actually telling its purpose. So if I am calling this is last in first out, last in first out, so here whatever the data we provide lastly as an input to this stack is come out first. That's why we call this as a last in first out. So the data inserted last comes out first from stack. This is the reason like we call this stack as a last in first out. So just keep me this here. Apart from this, so if I will again say this is a stack, so how do we store the data? So here the insertion is happening at this end and deletion is also performed at this end only. So again, let me just go here. So we perform insertion at this end only. This is the end where we perform insertion. For insertion we go like this, and for deletion we go like this. So this is the only one end where we perform both the operations, insertion and deletion. So insert we perform here, insert. This was 30. So generally we call insert as a push operation. We are inserting the data means we are pushing that data, and if we are deleting the data, so we are popping that data. So these are the different names which are coming here. So if I will say I am removing data, so delete means we are popping the data. So these are the names which we should just remember. Delete operation we generally call as pop operation, and the place where we perform this insertion and deletion we generally call as a top. Okay, so let me just mention. So how the items are stored? So items are stored here like this, like this. I'm just making some sections like this we perform. So here we can say like we can have number of items stored inside this stack. So stack generally is nothing but any kind of box which has a same end for adding the data as well as for removing the data. So here you can say this will hold the index 0. This might be your index 0. Next to that you can have again next successive index. So I will just add like this. This was 0. This was 1. It was 2. And this is 3. So all the time the index will start from 0, and successively it will increase. Gradually you can just increase that. So this is how you can represent the indexes. So I hope you can see this. So here one term is again important, that is a top. So the place where we are adding the data as well as removing the data, we call this end as a top all the time. From the top of stack, we are allowed to insert and delete your data. So all the time remember some important point. This is a last in first out kind of data structure, as well as this is we call as LIFO just because of that name, last in first out. And the data is inserted as well as can be deleted from the same end. Okay, that's why here we just use that same end for both the operations. Here we use the names for insertion as push, and for deletion we renamed it as a pop. So you can use any name, it's not mandatory, but standard names are this push and pop for performing insertion and deletion. Apart from that, the last point I told you, like here the place where we are performing insertion and deletion is what, that is top. So remember this one. Okay, so elements we can store like this. If I just want to store now the elements here, if I want to pu- push the elements, so all the time if I am pushing here, let's say some a, so a will occupy what position, a will go at the index 0. Okay, after that let's say I am just adding here the new node which maybe let's say b, so b will occupy the next index, that will be index number 1. Okay, next to that if I want to again add c, so c will occupy the index number 3 here like this. What if now I want to delete, I have just added 3. Okay, again I will add one more because I have added there one more index. Okay, so I have added as of now ABCD like this. Now I want to delete, let's say D. So you know that the deletion will be done based on this methodology, which is last in first out. So all the time the D will remove first from your stack. Okay, though you want to delete any other element, the D should be come first because it's at the top. So D will go out first. Then let's say I want to again perform the pop operation, that is delete operation. So C will go after that. If I want to again delete A rather than B, so again I need to first pop B, then you need to pop A like this. It will happen. So similarly, we should use the same principles for implementation of your stack. So what I will do is again I will require to go on the same window, which is this one. So the stack consists of what? Stack consists of some uh, things here, like we should have a size of stack. This index is representing what? That is representing size of your stack. Parallelly, we should have here a some node which is allowing to insert your data and delete your data. We are calling that as a stop. So I will declare here the separate class for stack. I am just naming it as a stack only. Okay, so this thing we can perform. So here I'm making all the things public. Why? Because in upcoming again recursive or non-recursive traversal, like for non-recursive traversal, we require these stack operations to get out there. That's why we require the data members public. So the first thing that I require is a top. So I will say that is integer type, because the position of top will tell you whether your stack is full or not. So I'm just saying it's int top. Next, for the same node class, I can have a size of my stack. So I will just make node star st of, let's say, some size. So this is what, this is we can say a pointer array for your previous class, that is node. So I have defined here some pointer array. I have named it as a st. You can name anything. Okay, so the size is here 50, means you can store maximum 50 nodes inside your stack, which will follow again the minimum index, what it will be 0, and maximum it will be of 49. So these are only two things we require. First is stop and second is the size of stack. Apart from this, now what we can do is we can just initialize your stack. So initialize means whenever we will create any object or instance of the stack, initially the constructor will be called. So initially whenever you are initiating any stack, so the top will be -1. Why it's -1? Because initially the stack should be empty. Okay, we know that the minimum index of stack is what, that is here -1. So -1 means we are allowing at least one data here. that's why it should be 0. Okay, so if I am telling the no data is into stack, so top in that case will be what? Top should be -1. Less than 0 is -1. So this represents what? It's represent empty stack. Okay, so initially your stack will be empty. That is the meaning of this top equal to -1. Apart from this, what operation are being performed inside your stack? So we know that the very first operation is here, push, that is insertion. Sorry, push is here. This is it, push, that is for insertion, and next is pop. So we will think about this. So if we are using push operation, so we are allowing node to insert into your stack. So I will just use void push name. You can use again any name, but push is the standard keyword that we should follow, standard naming that we should follow. So what we are pushing, we are pushing some node. So I'm just getting the address of that root or that node from your previous node class. So I'm just declaring any temporary variable here, node star temp. So this is holding the address of that node. So we are passing that address through that pointer, which we are calling as a temp. So whenever you are pushing any node into your stack, that temporary variable or that temp will be stored where? It will be stored into your stack array or that st array. Okay, and if you are adding any element, so definitely this -1 should increment by one position. So initially this will extend, it will increment. So top will increment here, and after that it will store a temp. So what is the meaning of this statement now? Whenever you are pushing any node into your stack, so in that case, that stack array or that st array will first get increment, pre-increment we are doing, and parallelly we are storing temp node into your stack. So this operation will be only performed while pushing your new node into stack. So this is for just a push. So don't make the things again complex. This is the only operation which is performed in push operation. Next, we need to perform now pop. So the pop operation, if we are performing, so what thing we are doing, we are just removing the node from your stack. We are just removing that. So we have seen how we can remove. So if we are removing that node, so maybe while for printing we will require the address, because we require it actually for traversing. So what I will do is I will just get its address. That's why I'm writing here the type of that function is what? For pop, it's node star pop. So this function will return what? It will return the address of your popped node, the deleted node which you are going to remove from the top of your stack. So this function will simply return a decremented stack array. So it will decrement that. That's it. St of top minus minus. So this is it. This is push operation, this is pop operation that we have performed. Apart from that, we had done here initialization of that stack into that constructor. So this is the all operation that we have performed inside a stack. So where do we actually need to implement this? So as we are thinking about binary trees, so all the time we will require the stack if we are going for a non-recursive traversal. Non-recursive. Okay, so how to perform now this non-recursive traversal? We will see non-recursive pre-order. Into next video we will say this, because that is again the some different thing, but we require for that thing a stack. So this is just for this video. We will definitely see non-recursive pre-order traversal in next one. So thank you for watching this.